Indirect ELISA can detect both antibody and antigen. So, we have learned in the previous class that direct ELISA is useful for antigen detection, but in case of indirect, both can be detected. Now, first I will show you how to detect the antibody, then I will show you how an indirect ELISA will help you to identify a antigen. Now, this is antibody detection. Generally, indirect ELISA is used for antibody detection, but I will tell you both the ways. So, here you can see this is a well of a 96 well polystyrene plate. So, a single well. So, this is a single well from the 96 well polystyrene plate. Now, as you can see, I have drawn in the red color, this is the antigen coated wells. So, antigen coated wells are previously provided, that is kit provided. The company which is manufacturing the kit for any virus or bacteria have provided you the kit with everything, and that particular wells are coated with antigen. That antigen is against the desired organism's antibody you are searching for. Okay, so let's have an example. HCV, hepatitis C virus. Okay, so we are here to find the patient is either positive for HCV antibody. Okay, now these wells are coated with HCV antigen, and then the next step will be to inoculate the wells with patient serum. That patient serum, we don't know whether there is, if the patient is positive, they will contain the antibody. Okay, if the patient serum is negative for the virus, it will not have the particular antibody. So, patient serum, if it is positive, contains the antibody, also called, you can say, primary antibodies. So, this antibodies is specific for the HCV antigens. So, if it is present, this will bind to the antigens coated in the well. After that, you have to incubate and wash off the unbound antibodies. So, now we have primary antibody and antigens. Next step is to add the secondary antibody, which is enzyme conjugated. This is also kit provided. So, the company you are using for diagnosis, this will provide you these components. Okay. So, now you are providing secondary antibody, enzyme conjugated antibodies. So, if the patient is positive, we have already this structure present there. Now, this is the secondary antibody which is specific for the primary antibody. So, these antibodies, enzyme conjugated antibodies, will bind to the primary antibodies which are already bound to the antigen where it is coated into the wells. So, antigen, primary antibody, secondary antibody. We have the complete complex now. Then again we have to incubate and wash out all the unbound enzyme conjugated antibodies. Last day I told you that washing is a very important step. It should be done very carefully, otherwise it will give you a false positive and false negative results. So for your ease, you have not seen my previous video, go to the previous video. I will give the link in the I button. Now, the next step is after washing, you have to add the substrate. So, substrate, an enzyme needs a substrate to form the product. Product is the chromogen. Chromogen, I told you in the last class, is the product which will give you the color as you are going to analyze the result through spectrophotometer or ELISA reader in the form of OD value, that is optical density. Okay. This is our desired range of ODs. We will be comparing from positive to negative samples as well as positive controls and negative controls. So, after the adding of substrate, color will form in the form of chromogen. Then you have to add what? Stop solution. I also told stop solution is very much important to stop the enzyme at that place only, so that a weak positive patient may not show you a high positive reactions, because enzymes are made to utilize all the substrate that are present there. So as well as all the substrate and all the free enzymes are there will bind to all the substrates and form the color more deeply if you keep that for more longer time. So that is the thing here. That's why you should add stop solution. So this color formation will give you either it is positive or negative, but visually you can say, but you need to go for ELISA reader, and then you have to measure the optical density for each wells and compare it to the positive controls and negative controls to validate your experiment. So here, this indirect ELISA indirectly means that we are detecting the antibody which is present in the patient's serum. That's why it is called indirect ELISA. Okay, so antibody detection is complete. So now understand the concept of antigen detection through indirect ELISA. Now see the differences in the picture from the previous picture. Here the antigens in the previous picture was coated by the kit, by company. Okay, but here you are detecting the antigen, so the antigen here is coming from the patient sample. So if the patient is positive, then only the antigen will be present in the serum, and that will be adhered to the surface of the well after incubation. It may be 8 hours, maybe 10 hours, or maybe 12 hours depending on the kit manual. But you have to, the first step here is to, you have to add the patient sample or antigen into the well. So here the well was coming with non-coated. Just pause and revise the previous picture. That time the well was coated with antigens, but in case of antigen detection through indirect ELISA, the wells are not coated with either antibody or antigen. So the empty wells are first inoculated with patient sample and incubated. So after few hours, after the incubation, the samples, the antigens will be adhered to the wells. Okay, now this is, if the patient is positive, then only antigens will be there. Okay, that is the basic criteria. Now the primary antibody which was present in previous picture or the previous antibody detection, it was coming from the patient's serum, but here the primary antibody is kit provided. Whichever kit is you are using for, suppose that HCV you are detecting the antigen of HCV in this case. Okay, so this primary antibody is provided in the kit you are using, and that antibody will be binding to the specifically to HCV antigens if the patient is positive. So here I thought already, as I have drawn, patient is positive, antigen is present there, so primary antibodies will bind to the antigens present in the wells. So this is the second step. First sample, then primary antibody. Then you have to wash away the unbound particles of antibodies. Again, you have to add the enzyme conjugated secondary antibody, which is also kit provided. So this is the enzyme conjugated secondary antibody which is specific to the primary antibody. So those antibodies will bind to the primary antibodies. So now we have the triple layer complex of antigen, antibody, antibody. So two antibodies, one antigen, 3-layer complex. Then you have to add the substrate as the fourth step. It will produce a chromogen, and the fifth step is the stop solution. Then you will go for the ELISA reader and you will measure the ODs. So the first basic differences are non-coated wells will be taken, patient serum will be given first, it will be incubated, then primary antibody, then secondary conjugated antibody, and then as well as substrate and stop solution. So both the things are detected here through indirect ELISA, because the antigen is detected indirectly. The antibody was detected indirectly. So both the antibody and antigen detection are done by this indirect ELISA like this. So I hope I have cleared your concept. Thank you very much. So if you like my classes, give a big thumbs up and don't forget to subscribe my channel, because these things stimulate me to take futuristic classes for you guys. So thank you and be with me.